All right, welcome back. We're here with more with inverses, more fun with inverses. Let's look at one just from a graph, okay? So let's say that we're given a point, well, I'm sorry, a graph. Oh, why do I always do that? So I've got this point here, -5, comma, -5. Okay, this point here, -3, comma, 1. This point here, 1, comma, 2. And then this point here, 2, comma, 5. Okay, and then my graph just sort of connects these points. Okay, so one of the problems that I could get is I could actually ask you to draw the inverse. Okay, well, all that has to do to draw the inverse, or maybe pick out the inverse from a list of graphs. Okay, so to draw the inverse, we're just going to replace x and y. So switch x and y. Okay, so -5, -5 will be on the graph of your inverse. Also, instead of -3, 1, you would have 1, comma, -3. Instead of 1, comma, 2, you would have 2, comma, 1. And instead of 2, comma, 5, you would have 5, comma, 2. Okay, and then you could just draw away. Okay, simple as that, or as hard as that, however you want to look at it. Okay, now finally we're going to look at what's probably, it's not really hard, but it is the most algebraically intensive aspect of this section, and it's finding inverses of something like this. Y equals 6x plus 7 over 3x minus 4. Okay, so what we're going to do, we're actually going to do a couple of these just because it's a little bit intense. So we're going to solve for x. Now, this takes some algebraic doing. Okay, so when we solve for x, we're going to start by multiplying both sides by this 3x minus 4. Okay, 3x minus 4 times y equals 6x plus 7. Okay, now when we solve for x, we want to get x all on one side. So we're going to go ahead, we're going to distribute this y here. Okay, so we're going to have 3xy minus 4y equals 6x plus 7. All right, now what we want to do, we want to get all the x's on one side. So we're going to move this 6x over to this side and this 4y over to this side. How are we going to do that? Or basic algebraic structures or operations. 3xy minus 6x equals 4y plus 7. Next, on this left-hand side, we're going to factor out the x. x times 3y minus 6 equals 4y plus 7. Okay. Finally, x then equals 4y plus 7 over 3y minus 6. So you get f inverse of x equals 4x plus 7 over 3x minus 6. Okay? Simple as that. Now, one of the questions we might be asked is to find the domain and range of y. And that's going to actually work here. Okay, so the domain, remember, we cannot divide by 0. So 3x minus 4 cannot equal 0. Okay, so x cannot equal 4/3. But what about the range? Well, if you think about what taking an inverse does, okay, remember taking an inverse replaces the status of x and y. So it takes the status of x and it gives it that status to y. And likewise, it takes the status of y and gives that status of x. So you may be able to look at this and determine its range. Okay, I can, but I'm not expecting you to know how to do that just yet. Okay, but what we can say is that the range is the domain of the inverse. Okay, so we look down here at the inverse and we say, oh, here, what do I have to throw out? I have to throw out 2. Now, I don't like putting it here, but I'll write it. 3x minus 6 is not equal to 2. Okay, I don't, so, sorry, not equal to 0. So x is not equal to 2. That's not really the range, okay? That's just an algebraic way of describing the range. When we describe the range, really, it's going to be this interval notation. Okay? That way we sort of don't have this x and y involved in the explanation. Okay? So the range of f of x is the same as the domain of the inverse. Okay, let's do another one. Do another one on a new sheet of paper. Let's take y equals 4x plus 7. That's not the one I did before, right? No, okay. Y equals 4x plus 7 over 3x minus 6. Just want to make sure it's not the... That's actually the inverse. So let's change that all together. Let's see. If this were a class, this is when I would just ask you for numbers, but oh well. Let's take y equals 11x minus 3 over 19x plus 2. Okay, so now domain, I can't have 19x plus 2 is not equal to 0. x is not allowed to equal negative 2 over 19, negative infinity to negative 2 over 19, together with negative 2 over 19 to infinity. Let me put that in blue. Okay. Now let's find the inverse. Okay, finding the inverse, we're going to take y times 19x plus 2 equals 11x minus 3. Okay. Again, we're going to distribute this y here. Okay, so 19yx plus 2y equals 11x minus 3. Again, we're going to take all the x terms and put them on one side. So we're going to put all our x terms, I'm going to put them on the left-hand side. So 19yx minus 11x equals negative 2y minus 3. Now, I'm going to go ahead and factor out the x on the left-hand side. So x times 19y minus 11 equals negative 2y minus 3. Started writing it a little bit higher, just sort of getting ready for the next step. So x equals negative 2y minus 3 over 19y minus 11. So f inverse of x equals negative 2x minus 3 over 19x minus 11. So now, what is our range for our original function? Our range for our original function, well, that means you have to stay away from dividing by 0 down here. Okay, so 19x minus 11 cannot equal 0. 19x does not equal 11. X cannot equal 11 over 19. So negative infinity to 11 over 19 together with 11 over 19 to infinity. This is actually the range. This is just the algebraic equation that we use to find that value that we had to throw out. Okay. All right, let's do one more problem. We're going to go ahead, we're going to graph, or I'm sorry, find the inverse and graph. Let me just say it. Find and graph the inverse for f of x equals 2 plus the square root of x plus 1. Okay, so one thing that's going to help is if we graph this first. You don't need to graph it first, but it will help us. Okay, this is a square root function. Move to the left by 1 and up by 2. Okay, and you can tell if x is 0, you're going to have 2 plus 1. So this point is, in fact, 0, 3. That's going to help us with our finding the inverse. Okay, so y equals 2 plus square root of x plus 1. Now we're going to go ahead, let's move that, let's solve 4x. So y minus 2 equals square root of x plus 1. Now we're going to take, and we're going to go ahead and square both sides. Okay, we're going to square both sides. So y minus 2 squared equals x plus 1. Now, here's where we have to sort of be a little careful. Okay, when we did this, we may have accidentally introduced two values, right? So what are we going to need? Well, let's actually wait until we graph it, and then you'll see. So x equals y minus 2 squared minus 1, or f inverse of x equals x minus 2 squared minus 1. So we're going to start, we're going to go, this moves us to the right 2 and down 1. Now, you can already sort of guess we're only really going to get half of our parabola. This is a parabola, but it's really only half of it. What is going to be our restriction? Our restriction is, of course, x should be greater than or equal to 2. And you can actually see that from the original. The original has a range of 2 to infinity. Okay? So that's why our domain restriction on the new inverse should be 2 to infinity as well. Okay? All right, that's it for 1.7. I'll see everyone on 2.1 in the next section.